student, in the last video we completed the question 1, 2, 3, 4 of the exercise 1.3. Now in this video, the question number 5 to 9. In the question number 5, the given complex number in the polar form expressed in the coordinate form, that is z is equals to x plus iy, and also basic properties of the complex number in the remaining question. I hope that you will understand all the questions very easily. Now let us start the practice set 1.3, question number 5 to 9. Now let us see the express the complex number in the form x plus iy. Z is equals to root 3 cos of pi by 3 plus I times sin of pi by 6 plus I times sin of pi by 6. The value of cos of pi by 6 is root 3 upon 2 and sin of pi by 6 is 1 upon 2. Now multiplied with root 3 into root 3 upon 2 plus I root 3 into 1 upon 2, and their multiplication is 3 upon 2 plus root 3 upon 2 I. Next, second example, root 3 in bracket cos of 7 pi by 4 plus I times sin of 7 pi by 4. Z is equals to 7 pi by 4 plus I times sin of 7 pi by 4. Now see this, how to find out the value of 7 pi by 4. In the 10th standard, you have find out the value of up to 0 to 90, but here is a 7 pi by 4. Now I am expressing this value is like this. Pi by 4 means what? It is a 45. How many 45s we are requiring? The 7 pi by 4. Therefore, you have seen my terminal goes in the fourth quadrant. In the first quadrant, there is a 2 pi by 4. In second is also 2 pi by 4. 2 pi by 4, and last is also pi by 4. If you add this, that terminal goes in fourth quadrant. Now this can be written as, that is a 7 pi by 4 can be written as 3 pi by 2 plus pi by 4. Now see this, how I had written 3 pi by 2 plus pi by 4. But whenever the angle pi by integral multiple of the pi by 2 plus theta, the function changes. The function changes means what? Sine becomes cos, cos becomes sine, tan becomes cot, sec becomes cosec, is like this. Therefore, the cos of 3 pi by 2 plus pi by 4 is plus sine of pi by 4. Why the plus sign is given? Because in the fourth quadrant, cos is positive. Therefore, the final answer is 1 by root 2. Now see this. Sine of 7 pi by 4 is, again I had written the sine of 3 pi by 2 plus pi by 4. Now sine is negative in the fourth quadrant. Therefore, I had written the minus sign. And whenever there is a pi by 2 plus theta, then function becomes sine. Instead of the sine, becomes a cos. That is the minus cos of pi by 4. And the value is minus 1 by root 2. Now you can substitute the values. This is very important. That is, I had written the cos of 7 pi by 4, sine of 7 pi by 4 in this manner. That is integral multiple of the pi by 2 plus theta. The function changes. You remember this. And only next job is to substitute their values and get its answer. Therefore, z is equals to x plus I. Now next is to find out the values of these angles is very important. That is 7 in bracket cos of minus 5 pi by 6 plus I times sin of minus 5 pi by 6. Now here we required one more formula. You have learned that formula in 10th standard. That is sin of minus theta is minus sin theta and cos of minus theta is cos theta. one thing, how to remember? Sine reflect the negative sign and cos absorb the negative sign. See this, cos absorb the negative sign, that is the cos of minus theta is cos theta. How to remember? Trick for the remember. Sine reflect the negative sign, that negative sign comes outside, that is minus sin theta. In this way you can remember. That is z is equals to 7 in bracket cos of 5 pi by 6 minus sine of 5 pi by 6. Now see this, how to find out again the pi by 6. Now to find out the value of the pi by 6, my first is that is a pi by 6 means what? 30 degree. 30 into 5, that is 150. Pi by 6 means 30 degree. And 5 pi by 6 means what? That is 5 into 30 and it becomes 150. Now how you can write 150? That is a 90 plus 60 and it is written as pi by 2 plus pi by 3. Therefore, overall it is written as pi by 2 plus pi 60. Therefore, now we can write in this manner now. That is a 5 pi by 6 can be written as pi by 2 plus pi by 2 plus pi by 3 also I had written. And now see this, whenever the angle cos of 90 plus theta, then you are getting the minus sin theta. Whenever there is a pi by 2 plus theta, then function changes. Cos becomes sin and sin becomes cos in this way. Also, cos of pi by 2 plus theta is equals to minus sin theta. Because the cos in the second quadrant is negative, that's why negative sign is given, and sin in second quadrant is positive, parent is positive. Therefore, the sign of pi by 2 plus theta is positive there. That is which is the cos theta. Now, only the job is to substitute the values. See this. That is the cos of pi by 2 plus pi by 3. That is a minus sign of pi by 3. That is the cos is negative in the second quadrant. Therefore, I had written the negative sign. What about the sign of pi by 2 plus pi by 3? It's a cos of pi by 3. Now substitute the values. Sin of pi by 3 is root 3 upon 2 and cos of pi by 3 is 1 upon 2. Therefore, after the simple multiplication, you will get z is equals to minus root 3 upon 2 minus 7 I upon 2. Now fourth problem. Z is equals to r e raised to I theta. Now this is expressed in the exponential form, no problem. The value of r here is a 1. E raised to I by 3 into I. Now what is the basic formula? That is a r in bracket e r dot e raised to I theta means what? R in bracket cos of theta plus I times sin theta. Now what is our angle? Our angle is pi by 3. Therefore, the value of r is 1. Therefore, cos of pi by 3 plus I times sin of pi by 3 and the cos of pi by 3 it becomes 1 upon 2 and sin of pi by 3 is root 3 upon 2. I had written the value of r is also 1 here and that is z is equals to 1 upon 2 plus root 3 upon 2 I, or we can write also in this manner, that is a root 3 by 2 1 plus root 3 I upon 2. Now the problem number 5, e raised to minus 4 pi by 3 I. Now again z is equals to e raised to minus 4 pi by 3 I. It is written in this manner, that is a 1 dot e raised to minus 4 pi by 3 pi I. Again basic formula, z is equals to e raised to r into e raised to I theta, that is a r cos of theta plus I times sin of theta. Now what is here theta? Theta is 4 pi by 3. Now again here is the pi by 3 angle. How many times we are recording the pi by 3, pi by 3, pi by 3 and pi by 3? 4 times. See this, the angle is negative. We will go the step by steps. What is the cos of minus theta? Cos absorb the negative sign and sin reflect the negative sign. This is the trick to remember for the trigonometric angle. That is sine of minus theta is a minus sine theta. It is reflected that negative sign. But what about the cos of minus theta? Is absorbed the negative sign. Cos of minus theta is cos theta. That is z is equals to cos of 4 pi by 3. Negative sign is absorbed. And here is a minus sine of 4 pi by 3. Negative sign is reflected, becomes a negative. Now how to express this 4 pi by 3? If number of the students fear to the trigonometry, and I had explained this trigonometry in very see this, that is 4 pi by 3. It is written is like this, pi plus pi by 3. Now also there is one more interesting formula, that is the cos of pi plus theta. And now see this trigonometry. Cos of pi plus theta is goes in third quadrant. In third quadrant, cos is negative, parent is negative, and the function remains as it is whenever there is a pi angle. When we learn in M1 trigonometry, you remember my words is like this, dialogue is like this. Whenever there is a pi plus theta, that is an angle, the function remains as it is. The cos remains cos, sine remains sine, and it goes to the sign in which that parent trigonometry function is present. Now my cos of pi plus theta is lies in third quadrant. Cos is negative in third quadrant, function remains as it is. Therefore cos of pi plus theta is a minus cos theta, and sine of pi plus theta is again a minus sine theta, because sine is also negative in the third quadrant. And next job is very simple, that is the z is equals to minus cos of pi by 3 minus I in bracket minus sine of pi by 3. We can substitute its values. Therefore z is equals to the value of the z. Now next, problem number 6. Z is equals to e raised to 5 pi by 6. Again here is a pi by 6. That is, it's of the type z is equals to r e raised to I theta. That e raised to 5 pi by 6 into I. The value of r is 1 again. Cos of 5 pi by 6 plus I times sine of 5 pi by 6. Now pi by 6 means 30 degree, 30 into 5. Again. Now see this. Now this angle is written as in this manner, 150, and it is written as pi by 2 plus 60. Just this type of the angle is repeated. That is a pi by 2 plus pi by 3. Therefore, I had written in this manner. Number of the student fear, they have the fear about the trigonometry. बरेच विद्यार्थी ट्रिग्नॉमेट्रीसाठी फार काढला विषय तर ट्रिग्नॉमेट्रीज मला जास्त अवघड जातं, परंतु ट्रिग्नॉमेट्री सगळ्यात सोपी आहे, त्याच्या ट्रिक्स तुमच्या लक्षात आल्या तर. बट वी हॅव cos of pi by 2 plus theta is minus sin theta because it goes in second quadrant. In second quadrant cos is negative, therefore it has a minus sign. And sin of pi by 2 plus theta is cos theta. Function changes whenever there is a pi by 2 plus theta. And sin is positive in second quadrant, therefore it is a plus cos theta. Now see this. There is a minus sin of pi by 3 plus I times sin of pi by 3, and substitute the value of pi by 3. What is the pi by 3? That is, it is a root 3 upon 2 plus I times sin of 1 upon 2. That is a minus root 3 plus I upon 2. And now next, find the modulus and the argument of the complex number 1 plus 2i upon 1 minus 3i. This type of the examples we have completed also in the previous questions. Now see this. Z is equals to 1 plus 2i upon 1 minus 3i multiplied its conjugate. That is a 1 plus 3i to the numerator and the denominator, and then simplify. Normal simplification is there. To the denominator 1 minus 9i square, it becomes 1 plus 9, that is 10 to the denominator. Now simple multiplication is here. 1 plus 5i plus 6 into I square is minus 1. And that's why that is 1 plus 5i minus 6 upon 10. That is minus 5 plus 5i upon 10. Take 5 as a common. Therefore, you will get minus 1 plus I upon 10. That is minus 1 plus I upon 2. Therefore, z is equals to minus 1 upon 2 plus I upon 2. Therefore, z is equals to x plus iy. Now to find out the modulus, that is the mod of z is equals to, I always express the complex number in this fashion, that is z is equals to x plus iy. The value of the x is minus 1 upon 2 and y is 1 upon 2. Mod of z is equals to r is equals to in under root of x square plus y square. That is minus 1 upon 2 bracket square means what? 1 by 4 plus 1 by 4. If you add it, then you are getting the 2 by 4, which is nothing but in root of 1 upon 2. Therefore, the mod of z is equals to 1 upon 2. R is equals to 1 by root 2. And next we want to find out the amplitude also, that is argument. It is the tan of theta is equals to y upon x. That is 1 upon 2 minus 1 upon 2. It's a minus 1. Now see this. What I had written. 1 means what? Tan of pi by 4. Absorb the negative sign. That is a pi minus pi by 4. Therefore, it becomes 3 pi by 4. 4 into 5, that is pi minus pi, that is 3 pi by 4. Therefore, theta is equals to 3 pi by 4. Therefore, the modulus is 1 by root 2 and its argument is 3 pi by 4. Now next, convert this complex number in the polar form. Though if you see this problem, it will be very complicated, but it's very simple. That is z is equals to I minus 1 cos of pi by 3 plus I times sin of pi by 3. Substitute the value of I minus 1. Pi by 3 is 1 upon 2 plus I, that is root 3 upon 2i. Add it. 1 minus I, that is take 1 upon 2 common, then you will get in bracket 1 plus root 3i. Therefore 2 in bracket I minus 1 upon 1 plus root 3i. Now again the simplification is there. Multiplied the conjugate of 1 plus root 3i, which is the minus, that is 1 minus root 3i, to the numerator and the denominator. Therefore, you will get simple multiplication is there, that is 2 in whole square bracket. I is multiplied with 1 minus root 3i and minus 1 is multiplied with 1 minus, and to the denominator a plus b into a minus b means what? A square minus b square. It's very again the simple. Therefore 2 upon 4 in the bracket you are getting, that is I minus root 3 into minus 1 minus 1 plus root 3i, that is equals to 1 upon 2 I plus root 3 minus 1 plus root 3i. Therefore, it is written in this manner, minus 1 plus root 3. This is the real part, and imaginary part is 1 plus root 3 into I. Therefore, minus 1 plus root 3 upon 2 plus 1 plus root 3 upon 2 into I. hence z is equals to x plus iy. X is equals to minus 1 plus root 3 upon 2 and y is equals to 1 plus root 3 upon 2. Now again r is equals to in root of x square plus y square, that is minus 1 plus root 3 upon 2 whole bracket square plus 1 plus root 3 upon 2 whole square, that is equals to 1 by 4 in bracket 1 plus expand it, that is a minus 1 plus root 3, I had explained it, that is 1 minus 1 square, root 3 square is 1 plus 3, that is, and middle term minus 2 into 1 into root 3, and to the denominator also, that is, it is written as in this manner, take 1 by 4 as common, then you are getting the 1 plus 3 is 4, minus 2 root 3 and plus 2 root 3 get cancelled, plus 4. That is overall it is become 4 plus 4, that is 8 upon 4, that is root 4. And therefore the value of r is root 2. Therefore, now we will find out the argument, that is, now its amplitude tan theta is equals to y upon x, that is the value of the y is 1 plus root 3 upon 2 and value of x is minus 1 plus root 3 upon 2, that 2 get cancelled, and this is also treated as its argument. Also we can simplify this, that is multiplied n and d by minus 1 minus root 3 minus 1 plus root 3 into minus 1 plus root minus 1 minus root 3. Therefore, to the numerator normal multiplication, I have taken the minus sign from the second term, that is the minus in bracket 1 plus root 3 into 1 plus root 3, and to the denominator minus 1 square minus root 3 square, that is 1 minus 3 to the denominator. Now expand this. See this? Minus minus again become plus to the numerator and the denominator. Next is 1 plus root 3 upon 2. 1 plus root 3 bracket square upon 2. Expand it again. I had written first the square terms. 1 square plus root 3 square means what? 3. That is 1 plus 3 plus 2 root 3 upon 2. And normal their addition, that is the tan theta is equals to. Now this is also treated as argument also. Tan theta is equals to 2 plus root 3, you can also simplify. Therefore, in the polar form, z is equals to r in bracket cos of theta plus I times sine of theta, and the value of the r is value of the theta, it's treated as like this, that theta is equals to tan inverse in bracket root 3 plus 1 upon root 3 minus 1 in this fashion. Now the question number 8, it's very simple question. For z is equals to 2 plus 3i, the basic properties of the complex number is here, and verify the following properties, that is z bar of z bar, that is equals to z bar, that is conjugate of conjugate, that is z is equals to 2 plus 3i, therefore z bar is a 2 minus 3i, and again it's a bar, that is a conjugate of conjugate, that is again the, it becomes minus, become again the plus, and which is nothing but the z, that is a conjugate of conjugate, that is equals to z. Now next property, z into z bar is equals to mod of z square. That is z is equals to 2 plus 3i, z bar is equals to 2 minus 3i, and mod of z is equals to in under root of 2 square plus 3 square, that is 4 plus 9, that is equals to 30. That is mod of z is equals to root of 13. Also, z dot z bar, that is a 2 plus root 3i, 2 minus root 3i, their multiplication is a plus b, a minus b of the form, that is a square minus b square, that is a 4 minus 9i square, that is a 4 minus 9 into minus 1, that is a 4 plus 9, that is equals to 13. That is z dot z bar, that is equals to 13, that is nothing but the mod of z square. Hence, next, that is z plus z bar is real number. That's very clear that is a z means 2 plus 3i and z bar means 2 minus 3i. Add these two terms, then you are getting the 2 plus 3i plus 2 minus 3i plus 3i minus 3i get cancel. That is 4 is a real number and it is proved. Next is z minus z bar, that is equals to 6i. Again, this is very simple. That is a 2 plus 3i and z bar is a 2 minus 3i. If you take the subtraction, 2 plus 3i, added, taken the first of all their addition is a real number and their subtraction z minus z bar. This is our question, that is a 2 plus 3i minus bracket 2 minus 3i and that is equals to 2 plus 3i minus 2 plus 2 get cancelled and you are getting z minus z bar is equals to 6i. Now next property, conjugate of z plus z1 plus z2 is equals to z1 conjugate plus z2 conjugate. If you add these two, z1 and z2, and if you take their conjugate, and their conjugate is a 3 plus z1 plus z2's conjugate is 3 plus 2i. This is 1. Means what? First add them and find out their conjugate. And what is in second case? Take their conjugate individually and add them. And therefore from 1 and 2 both are same. Very basic properties there. Next is subtract z1 minus z2, their subtraction, and find out their conjugate. That is a minus 1 plus 4i and take their conjugate. Therefore, it is a minus 1 minus 4i. This is equation number 1. And next is z1 bar minus z2 bar. After their taking the conjugate and subtraction. 1 minus I minus 2 minus 3i. That is a minus 1 minus 4i from 1 and 2. Therefore, z1 minus z2's bar is equals to z1 bar minus z2 bar. Now third, z1 into z2 bar is equals to z1 bar dot z2 bar. Now again find out the multiplication. 1 plus I into 2 minus I. Normal multiplication is there. That is 1 is multiplied with the 2 minus 3i. Again I is multiplied with 2 minus 3i. Their simple multiplication. The value of I square is minus 1. And that is 2 minus I plus 3. That is 5 minus I. Now next is z1 into z2 bar is again it's a 5 plus I. Now there find out their individuals, that is a Z1 bar dot Z2 bar, and there again multiplication, again both these terms are same, that is simple multiplication is there, 2 plus 3i minus 2i minus 3i square, and that's why you are getting the 2 plus I plus 3, that is a Z1 bar into Z2 bar is equals to 5 plus I. Therefore, from one end to, that is you are getting the Z1 dot Z2 bar, that is next. There are now division in the form, that is Z1 upon Z2 bar is equals to Z1 bar upon Z2 bar. Now Z1 upon Z2 is equals to 1 plus I upon 2 minus 3I. Now multiplied with its conjugate, that is in bracket 1 plus I, 2 plus 3I upon 4 minus 9I square, and that's why normal multiplication and simplification is there, that is a 2 plus 3I plus 2I plus 3I square, I square the values is minus 1, that is a 2 minus 3 plus 5I upon 13, that is a minus 1 plus 5I upon 13, that is a minus 1 plus minus 1 upon 13 plus 5 upon 39. Therefore, Z1 bar upon Z2 bar, that is a minus 1 upon 13 minus 5 upon 39, and Z1 upon Z2 bar is equals to, now find out this also, they are substituting the values, take their conjugate, that is 1 minus I into 2 minus 3I, 4 minus 9I square, that's why you are getting 1 in bracket 2 minus 3I minus I in bracket 2 minus 3I, 4 plus 9, that is the normal simplification is there, minus 3I square means what? 3, that is 2 minus 3 minus 5I upon 13, and in this way minus 1 upon 13 minus 5 upon 39, this is the number 2, and that's why from 1 and 2 the LHS is equals to the RHS. In this way, we have completed the practice set 1.3, and in the next video we will see the de Moivre's theorem and the cube root of unity and their properties. If you have any doubt, you ask me in the comment box. Now we'll see in the next video. Till then, goodbye. In this way, we have completed exercise 1.3 completely. I hope that you have understand all the problems, whatever I have explained. Till then, if you have any query, write in the comment box. Also, if you are new for this channel, then subscribe it and share it with your needy friends. Now we'll see in the next video, that is the practice set 1.4 de Moivre's theorem. Till then, goodbye.